This video will show you a demonstration for how to add more complicated constraints to solver. So we still want to solve for optimized portfolio and subject to some constraint. So we're going to use solver to add those constraints. So we're going to have the objective function here equals to theta. By changing from 10, let me just close it. We need some initial value here. So this is the sum, this is the theta. I'm making sure that every formula is correct. And this is the mean and sigma, good. Here, the objective function is here to maximize theta. So maximize, check this box to maximize theta. And theta is B19 by changing value of x1 to x4. So we don't need B10 here. And then subjects to constraints. So here, 11 to 14 means the weight. So we don't want the weight to be greater than 40, and the minimum is also 5%. So add this constraint here. And the original constraint we have is adding the sum of all those weights together equals to 1. And that's good. We don't need to check this box because the minimum weight will be 5% anyway. So we can just click solve. Okay, so we can just check it and see the minimum here is 5% and the maximum is no more than 40%. But without these two constraints here, the weight is 58% for x1 and 0% for x4. So here we increase it to 5% and then 40%, reduce it to 40% for 1. This is a very realistic assumption here because some of those mutual fund or portfolios, they don't want to have a dominant holdings. So they want to show that they're evenly or they're well diversified, that they're evenly distributed, the weights are evenly distributed. So they want to keep the weights to be very similar within a very proper range.